Okay, Longhorns, so this is the video of me filling out your Test 8 review, and it's Review. I believe your copy has this correction in it, so you might want to just change that to Review review. There's a little typo there. And we're going to go ahead and start with number 1. And it asks us to convert this 3 pi over 7 radian angle measure to degrees. So the way we do that is we take our radian and we multiply it times 180 degrees over pi. So what happens here is the pi's cancel out, and then we just multiply everything else across and divide. So we have 3 times 180 divided by 7, and when we put that in our calculator, we get 77.143 degrees. And that's it. Number 2, we're doing the opposite. We're doing 185 degrees. We want to change that into radian measure, so we're going to multiply times pi over 180. So here the degrees cancel out, and we're left with 185 divided by 180, and 185 divided by 180 gives us 37 over 36. So this is going to be 37 pi over 36, and we want to leave it in terms of pi, so we're not going to multiply times pi. We're going to leave pi alone. All right, number 3, we're converting from degrees in decimal form to degrees, minutes, and seconds. So the first thing we're going to do is we're going to keep the first part, which is 143. And then we're going to take the decimal part, this 0.29, and we're going to multiply times 60. And when we do that, we get 23.4. 23.4. So the 23 part here is going to be our minutes. So 143 degrees, 23 minutes, and we use a little hash there for minutes. And then this other 0.4 that we have here, we're going to multiply that times 60. 0.4 times 60, and that gives us 24. So we're going to have 143 degrees, 23 minutes, and 24 seconds. And that's all, and we're finished. All right, problem number 4. We're going to do the same thing in reverse. So we take our 22 degrees, we're going to keep that. So we keep our 22 degrees. And this time we're going to add, we're going to take the minutes, the 14 minutes, and I'm going to divide that by 60. So I'm doing the opposite operation I did before. I'm dividing this time. And then I'm going to add, and I'm going to take my seconds, and I'm going to divide that by 60 times 60, which is 3,600. And when I put that in my calculator, I get 22.238 degrees. And that's what that is in decimal form. Okay. The next problem is a word problem, and I'm going to make this a little bit smaller so we can see the whole word problem. And we did one in class similar to this as a warm-up, and so we're going to use the same process that we used in class during the warm-up. And here we are, we're talking about Gemini. She's about to run a relay race on a circular track that has a radius of 8 meters. Her track partner is standing 18 pi over 23 radians away from her. How many meters does Gemini need to run to pass the baton to her partner? Well, we're going to use our arc length formula. S equals R theta. Well, we know that R is 8 meters, and theta is 18 over 23 pi. So we just put that in our calculator, and Put it in just like that. And when we put it in the calculator, we get 19.669 meters. And that's it. All right, for the next one, the dartboard of a diameter of 24 inches has 12 equal sections. What area of the board does each section cover? In this case, we're going to be using our area of a sector formula, which is A equals 1/2 r squared theta. Okay, so we know that we have our 1/2. The radius is going to be half the diameter, which is the diameter is 24, so half the diameter is going to be 12. So it's going to be 12 squared for r squared. And theta is going to be 2 pi, except we're only going to use, we're only going one section around, so this 1/12 times 1/12. So we're using 1/12 of 2 pi or 1/6 pi. So whichever way you want to calculate it, it's fine. You can put this entire thing 1/2 12 squared times 2 pi times 1/12, and when you put that in the calculator, you get 37.699 inches squared. So let me write that in. 37.699 inches squared. All right, in the next word problem, we have Redenbecker manufactures circular saws with a blade diameter of 8 inches. If the blade spins at 3,000 revolutions per second, what is the angular velocity of the blade? Well, this question specifically asks for angular velocity, so we're going to use our angular velocity formula. And our angular velocity formula is omega equals theta over time. Well, we know that theta is 2 pi because every time we go around the circle, we go 2 pi. And we're doing that 3,000 times, so we need to include our 3,000 revolutions here. So 3,000 revolutions times 2 pi. And then we need to put in our time, which is per second, so 1 second. So our final answer is going to be, when we put that in the calculator, 18,849, let me see if I can fit it in here, 18,849.6 revolutions per second, RPS, revolutions per second. Okay. In the next word problem, we are on a carousel with a radius of 10 feet and revolves at 3 revolutions per minute. How many miles per hour is it going? All right, so this is the one that we need to do some conversions. So I'm going to try to write as small as I can here. All right, so first of all, we want, in this case, we want to know our linear velocity because we're talking about miles per hour. So for miles per hour, that's going to be linear. All right, so we want the formula for linear velocity. And the formula for linear velocity is V equals radius times theta over time. All right, well, we know that the radius is 10 feet and theta is going to be 2 pi. And we also know that it goes 3 revolutions per minute, so we're going to do times 3 revolutions. All of that over time, which is per minute. So 1 minute. Okay, so far so good, but now we're going to have to do some conversions because they want their answer in miles per hour. So we have to convert minutes to hours. Well, there's 60 minutes in an hour. And we also have to convert feet to miles. and there are 5,280 feet for 1 mile. Okay. Now once we put this in the calculator, we get 10 times 2 pi times 3 times 60, and we divide by 5280, and after we do that calculation we get 2.142 miles per hour. Let's see if I can write that in. 2.142 miles per hour. Okay, now the next problem, we're going to find the angle that is coterminal with 420. So you remember with coterminal, we're just going around and around 360 degrees. So if I'm trying to find the angle that's coterminal with 420, I take my 420 degrees and I subtract 360. And what I get is 60 degrees. So 60 degrees is coterminal with 420 degrees. They end at the same ray from the standard position. So 60 degrees would be my answer for this question right here. Okay, now in number 10, you're going to have to use your calculator, and you're going to have to calculate cosine of 160 in your calculator. Now, in your calculator, you need to make sure that your calculator is in radian mode, which you're going to have to go to settings to check that. So you go to settings, document settings, and just make sure that the second box there says radians, that you're measuring your angles in radians. If that's okay, then you're good to go. Go back to the calculate screen, and you're going to push the trig button. And there all of your trig functions pop up. You're going to push cosine, then you're going to push 160, and then you're going to push the pi button, which gives you the option to put in your degrees. So you put in your degrees, you close your parenthesis, and hit enter, and you should get negative 0.940. That is your cosine of 160 degrees. And the next two problems, we're going to do the same thing. So for problems 11 and 12, you're going to use your calculator again, and you're going to follow the same steps you did for number 10. So sine of 73 degrees on my calculator came out to be 0.956. And so I want you to go to 3 decimal places on these, 0.956. So number 12, tangent of 130 degrees is negative 1.192. So these you're definitely going to have to do in class if you don't have a TI Inspire calculator at home. Or you can use any calculator that you're able to do trig functions on, and you should be able to do it using it, but you have to make sure that you're measuring degrees and not radians. Okay? All right, so question 13, using the unit circle, evaluate sine of pi over 4. So in this case, you get to use your unit circle. And you're going to look at your unit circle where pi over 4 is, and you will see that the sine of pi over 4 is root 2 over 2. So you need to know how to use that unit circle. We practiced this a lot in class, but if you still need more practice before the test, you need to go ahead and take some time to practice some more problems. Problem number 14, using the unit circle, evaluate cosine of pi over 6. Cosine of pi over 6 is root 3 over 2. And number 15, using the unit circle, evaluate tangent of pi over 2. And we know that tangent of pi over 2 is undefined. Okay, so problem 16. And problem 16 is a little more involved. And so I'm going to go ahead and use this space down here to work problem 16 for you. And what you're going to have to do also for the test is explain in your own words how you did problem 16. So down here in this blank space next to the formulas, I'm going to go ahead and make a diagram of what we need to do. All right, so our point is negative 3, 4. So if I draw a coordinate plane, okay, and I go negative 3 and up 4, that puts me right about here. Okay, so this forms a triangle like this, where this side here is a right angle. And what we're measuring is this theta right here, this corner. So if I was to make a circle, it would go around like that. And this would be our point at the end of the circle. So what we need to do is we need to write down our side measurements. This side is negative 3, and this side is 4. And then we're going to have to use the Pythagorean theorem to find the hypotenuse. So you can take a moment to figure that out on a piece of scratch paper. You know how to do the Pythagorean theorem. You'll find out that this side right here is equal to 5. So what I'm trying to do is find the sine, cosine, and tangent of this angle right here, theta. Okay? So we're going to use our trig ratios that we practiced, and we're going to determine what the sine, cosine, and tangent is. Sine is side opposite over hypotenuse. So side opposite is 4 over hypotenuse is 5. So sine of theta is 4/5. Cosine of theta is the side adjacent or adjacent to the angle theta. So that would be the negative 3. So negative 3 over 5. And tangent is sine over cosine. So this would be 4 over negative 3. And that's it. That's all you have to do for number 16. You're going to have to describe that, though, in your own words. So think about how you want to word that on the test, because you're going to be writing a paragraph about it. Okay, let's go back to problem number 7 real quick. I made a mistake earlier when I said that the answer was 18,849.6 revolutions per second. That is actually radians per second, not revolutions. So I don't want you to get confused. That's radians per second, not revolutions. So that's it. That's the end of the review. If you have any questions, make sure you ask them before you get your test. Good luck, Longhorns.